Hello everyone, welcome. So first of all, I'll thank you each and everyone for enrolling in this course. So in this course, we're going to start analytical geometry, which comes under paper 1 of UPSC mathematics optional, right? Yes. So I have given you the detailed syllabus of analytical geometry. I have classified the syllabus into 7 major topics. The first is direction cosines and direction ratios, planes, straight lines, sphere, cone, cylinder, paraboloid, ellipsoid, and hyperboloid. Right? These are the 7 major topics that we're going to cover in analytical geometry. At the end of the course, I'll assure that whatever problem they ask in an exam point of view, you can do it provided if you have a good practice, right? Okay. And throughout the course, we're going to follow 2 major books. The first book is PNC Solid Geometry. The second book is Krishna series on analytical geometry. Both books are available in my Telegram channel. Telegram channel name is Math Press, right? You know. So I'll just post those 2 books PDF in those group in that group itself, right? Yes. And there will be approximately 40 to 60 marks, right? There will be 40 to 60 marks only from analytical geometry, right? It's a very interesting topic, but a lot of students will feel difficulties in analytical geometry. But if you understand the concepts geometrically, then this is one of the easiest topic, right? We will start very easy. Okay. So the first topic that we're going to cover is direction cosines and direction ratios. So in direction cosines and direction ratios, we will have many parts, right? So these are the major classification. We're going to discuss each and every topic in very detailed manner. And in that series, the first topic we're going to start, which is direction cosines and direction ratios. In that, this is part 1, right? So this is part 1 of direction cosines and direction ratios. So we will have many parts only on direction cosines and direction ratios. After completing that, we will be moving on to planes. In planes, we will have many parts. After that, we'll be moving on to straight line, sphere, cone, cylinder, paraboloid, ellipsoid, and hyperboloid, right? Okay. In this video, what we're going to do is that this is part 1 of direction cosines and direction ratios. We're going to cover the first 5 subtopics today, right? So in direction cosines and direction ratios, so these are the 5 subtopics, right? That is, first we're going to define what is meant by direction cosine of a line. We'll be defining what is direction ratio, and we'll be seeing what is the relation between direction cosine and direction ratio. And the fourth one is what is the direction cosine of a line joining 2 points, right? Of a line joining 2 points. And what is the projection of a line joining 2 points on another line? So these are the 5 subtopics that we're going to cover in this video. And from next part, we're going to do some problems based on the above 5 subtopics, right? Yes. So first we will start what is meant by, we will be defining what is meant by direction cosine of a line, right? So very, very interesting topic. So we will start, right? We will define what is meant by direction cosine of a line, right? Okay. So we will define direction cosine of a line, right? So direction cosine of a line, right? Yes. So let AB be the given line, right? So we have a line AB, right? So we have a line AB. So let AB be the given line, right? Let AB be the line. Right? So what we need to find is we need to find the direction cosine for this line AB, right? So what actually it means is let us draw a coordinate system, right? Let's start a coordinate system. Let this be x-axis, and let this be y-axis, and let this be z-axis, right? Let us say this is our line AB, right? Let us say this is our line AB. This is our line AB, right? So we need to find the direction cosine for this line, right? So to find the direction cosine for this line, what you need to do is, what we will be doing is, we will be drawing a parallel line that passing through origin, right? So you just draw a parallel line that is passing through this origin, right? So what I'm going to do is, I'm going to draw a parallel line that is passing through origin, right? So you can see, I'm going to draw a parallel line. I'm going to draw a parallel line that is passing through origin, right? So you can see these 2 lines are parallel, right? These 2 lines are a parallel line, right? Now, let us take a point P in this line. Let us call that point as x, y, z, right? Yes, right? So, we need to find the direction cosine for the line AB. So A is some point in 3D space, B is some point in 3D space. So I'm drawing a parallel line that is passing through the origin, right? Yes. So draw a line OP that is parallel to the line AB, right? Draw a line OP that is parallel, to AB and passing through origin, right? There will be many lines that will be parallel to AB, but you draw a line that is passing through origin, right? So draw a line OP that is parallel to AB and passing through the origin, right? And passing through the origin, right? Now very easy, right? Okay. Now you can see this OP. This OP makes some angle with x-axis. This OP makes some angle with y-axis, and this OP makes some angle with z-axis, right? Remember, this is a 3-dimension, right? You need to see this in a top view. So you just see this in top view, right? So you can see, if I see this in top view, you can see this OP. This OP makes some angle, right? So don't consider this line, right? So we will restrict only to O to P. This is extension of OP. So we'll consider only from O to P, right? So let alpha be the angle. Let alpha be the angle, right? Alpha be the angle made by this OP on x-axis, right? That is, this angle is alpha, right? So this OP makes an angle alpha with the x-axis. Let beta be the angle. Let beta be the angle made by OP on y-axis, right? On y-axis, that is, this OP makes an angle beta with the y-axis, and let gamma be the angle, made by OP on z-axis, right? So we have 3 angles, that is, this OP makes an angle gamma, right? So this OP makes an angle gamma with the z-axis, right? So we have alpha, beta, gamma. This alpha, beta, gamma are called the directed angles, right? So these alpha, beta, gamma are called the directed angles, right? Are called the directed angles. So we're going to call these as directed angle. Cosine of these directed angle is called the direction cosine of the line. The cosines of these directed angles is called the direction cosines of the given line, right? Of the given line. That's it. Very easy. So that means you just take cos for these 3 angles, right? Alpha, beta, gamma, the angle. You just take the cos for those 3 angles. You will be having a triad, right? That is a triplet. That is cos alpha. Okay, I just change the color. So cos alpha. I'm going to take cos for all 3 angles. So cos alpha, cos beta, cos gamma is called the direction cosine for the given line, right? So from now on, we will be denoting this as L, M, N, right? So we will be denoting this as denoting this as L, M, N, right? So what is L? L is cos alpha, M is cos beta, N is cos gamma. That is, so L is equal to cos alpha, M is equal to cos beta, N is equal to cos gamma, right? So that means we have defined direction cosine of a line, right? Remember, line can be whatever line, right? It can be anything, but you just draw a parallel line that is passing through origin, right? That is passing through origin. Then that parallel line passing through origin will make some angle alpha, beta, gamma with x-axis, y-axis, z-axis respectively. This alpha, beta, gamma are called the directed angles. Cosine of these angles is called as direction cosine of the given line, right? So usually from now on, we will be denoting this as L comma M comma N, where L is cos alpha, M is cos beta, N is cos gamma, right? So these are the direction cosine of a line. Now we're going to discuss some very important, three important note based on direction cosine of a line, right? Three important note. The first note is, right? So note one. So these three are very important note, which follows from the definition, right? The first note is if L comma M comma N are direction cosine or direction cosines of the given line of a given line of a given line of a given line, then L square plus M square plus N square is always equal to what? Very, very important result, right? So we will prove this. So from this result, we will be getting a very good idea about what actually direction cosines are, right? Okay. What is L? L is cos alpha, M is cos beta, N is cos gamma. That is, if you square it and sum it up these three angles, you will always have equal to 1. That is first note, right? If L comma M comma N are direction cosines of a given line, then L square plus M square plus N square is always equal to 1, right? So we will prove this, right? Now we will prove this. Proof is very easy. So we'll prove this, right? So first we'll draw the coordinate axis, right? And let us say this is our this is our x-axis, and this is our y-axis, and this is our z-axis. And in the previous slide we have seen, let us draw a line OP, right? So this is our origin, and this makes an angle alpha, this makes an angle beta, and this makes an angle gamma, right? And this is our origin O. Okay. Now we need to prove L square plus M square plus N square is equal to 1, right? So before that, what we will do is we will call this point as x comma y comma z. Right? This is a coordinate P. So let's call this as x comma y comma z, right? X comma y comma z. Okay. Now we have what is OP? What is OP vector? So it is nothing but xi vector plus yj vector plus zk vector. Yes or no? So this OP vector is nothing but xi plus yj plus zk, right? Because this point is x comma y comma z, and this position vector xi plus yj plus zk, right? Okay. Now we need to prove L square plus M square plus N square is equal to 1, right? Now what is L? Before that, now what is the length of this OP? What is the length of this OP? What is the length? What is the magnitude of this OP? It is nothing but square root of modulus of xi plus yj plus zk. It is nothing but x square plus y square plus z square, right? So this distance is modulus of OP. So therefore, modulus of OP, this distance is nothing but square root of x square plus y square plus z square. If not, you can use the distance formula also, right? This point is 0, 0, 0, right? This point is 0, 0, 0. This point is x, y, z. What is the distance between these 2 points? It is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. You can get the same answer, right? Yes. Now, what is L? What is L? L is cos alpha, right? L is cos alpha. L is cos alpha. So what is cos alpha? Very easy, right? You just form cos alpha, right? Just make an angle cos alpha. So you can see this is our angle alpha, right? This is our opposite side, and this is our adjacent side, and this is our hypotenuse, which is nothing but the distance OP. So what is cos alpha? It is adjacent side divided by hypotenuse, right? What is adjacent side? You can see this is nothing but x, right? This is nothing but x divided by what is hypotenuse? It is nothing but square root of x square plus y square plus z square, right? Very easy, right? Opposite, adjacent. Adjacent is this distance, which is x, right? Because we are moving x distance here. Okay. Now similarly, what is m? M is cos beta. So cos beta is again adjacent side divided by hypotenuse, right? So with beta, you need to form a right angle triangle. So let us form a right angle triangle with angle beta. So you can see this is our right angle triangle, right? So you can see this is our right angle triangle, right? So you can see this is our base, right? This is our adjacent side, and this is our opposite side. And hypotenuse is again the distance OP, right? So what is cos beta? Adjacent by hypotenuse. So here our adjacent is this length, right? This length is nothing but y, right? This is nothing but y. So divided by root of x square plus y square plus z square, right? Yes. Now what is n? N is cos gamma, right? N is cos gamma, and again this is adjacent side divided by hypotenuse. So with gamma, you again form a rectangle triangle, right? You will be having z divided by square root of x square plus y square plus z square, right? Very easy. Now you just square it up and add it. Right? We need to prove L square plus M square plus N square is equal to 1. So we have L square plus M square plus N square, right? You can see all the bases are same. Okay, we will find L square now. So it is x square divided by x square plus y square plus z square plus what is M square? So it is y square divided by x square plus y square plus z square plus what is N square? It is z square divided by x square plus y square plus z square. You can see all the bases are same, so you can add the numerator. So you'll be having x square plus y square plus z square divided by x square plus y square plus z square, which is always equal to 1. So therefore, we have proved that if L, M, N are direction cosines, then L square plus M square plus N square is always equal to 1, right? Yes. So far what we have seen is we have defined direction cosine of a line, and then we have proved that if L, M, N are direction cosine, L, M, N is nothing but cos alpha, cos beta, cos gamma, right? And we have proved that it is L square plus M square plus N square is always equal to 1, right? Now we will be seeing note 2. So note 2 is again very important note, right? Note 2 is again very important note. So what it says is if L, M, N are direction cosine of a line, right? We have L, M, N as a direction cosine, that is cos alpha, cos beta, cos gamma. Then a unit vector, along the line is Li vector plus Mj vector plus Nk vector. Very beautiful observation, right? So what they are saying is if L, M, N are direction cosine, then Li plus Mj plus Nk will form a unit vector along the given line. I'll explain, right? Let's draw the diagram, then you'll have more clarity, right? So we have x-axis, y-axis, and z-axis, right? So we have x-axis and we have y-axis and we have z-axis, right? So let us say this is our line OP, right? This is a line OP, right? This is a line OP, right? Okay. This is our O and this is our P, right? So what they are saying is if L, M, N are direction cosine, then this vector is a unit vector along the given line. So what is unit vector? A vector of length 1, right? Magnitude 1. So then this vector, right? Let us say this coordinate is L, M, N, right? L, M, N, this coordinate. Then Li plus Mj plus Nk is a unit vector along the given line. This OP magnitude can be anything, but this L, M, N, right? The distance from O to L, M, N will always be equal to 1. That means what? Unit vector along the given line is Li plus Mj plus Nk, right? If L, M, N are direction cosine, then a unit vector along the line is Li plus Mj plus Nk, right? Why it is unit vector? Because what is the length of Li plus Mj plus Nk? This is our vector Li plus Mj plus Nk, right? What is this distance? This is nothing but magnitude of Li plus Mj plus Nk, right? Because a position vector. Since the position vector, the distance will be modulus of this vector. If not, we can use the distance formula. This point is 0, 0, 0. This point is L, M, N. So you know distance between 2-point formula, right? Distance between 2-point formula, you know, right? This is nothing but square root of L square plus M square plus N square. And we already know L square plus M square plus N square is equal to 1, right? this will be 1. So therefore, this vector has magnitude 1 along this line. So therefore, this vector, what is this length? This length is 1, right? So this Li plus Mj plus Nk will form a unit vector along the given line. So whenever I say direction cosine L comma M comma N, that L comma L comma N will also be a unit vector along the given line. Very important note, right? I'm stressing this because we will be using this in later part of the video, right? If L comma M comma N are direction cosine, then Li plus Mj plus Nk will be unit vector along the given line, right? Okay, this is our note 2. Now we'll be moving on to note 3. So note 3 is we will be finding the direction cosines for coordinate axis, right? So direction cosines of the coordinate axis that is, if your line OP falls on x-axis, what is your direction cosine? If your line OP is same as y-axis, what is your direction cosine? If your line OP is same as z-axis, what is your direction cosine? That's what we're going to find, right? So we will be moving on one by one. So what is the direction cosine for x-axis? If this, okay, let us draw the diagram, right? I'll lay the same diagram, right? I'll lay the same diagram. This angle is alpha and this angle is beta, right? This angle is beta and this angle is gamma, right? If this line falls on x-axis, right, then what about this angle alpha? Alpha will be 0 degree. And remember, what is a very basic result about the three-dimensional system? All three are mutually perpendicular. That is, the angle between x and y is 90 degree, angle between x and z is 90 degree, and angle between y and z is 90 degree, right? So all three are mutually perpendicular. So that means if this OP falls on x-axis, our alpha will be 0 degree, right? Alpha will be 0 degree. So this will be, the x-axis is our line now, right? X-axis is our line now. This x-axis makes an angle 90 degree with y-axis, makes an angle 90 degree with z-axis. That means our beta will be 90 degree and our gamma will be 90 degree, right? So therefore, what is our direction cosine? It is L comma M comma N. So which is cos alpha, cos beta, cos gamma. So cos alpha is 0, right? So cos 0 again directly. So alpha is 0. So cos 0 is 1 and cos 90 both are 0. Right? Now similarly for y-axis, remember, this is a unit vector 1 comma 0 comma 0, right? Because the distance from 0 to 1 comma origin to 1 comma 0 comma 0 is 1, right? And also this magnitude is equal to 1. Okay. Now for y-axis, if y-axis is your line, then our beta will be 0 degree. Yes or no? Our beta will be 0 degree and our alpha and gamma will be 90 degree. Yes or no? Very simple, right? If this OP is same as y-axis, then beta will be 0 degree and this y-axis is our required line and this y-axis makes an angle 90 degree with x-axis and this y-axis makes an angle 90 degree with z-axis because all dimensionally perpendicular. As a result, our alpha and gamma will be 90 degree. In that case, our L comma M comma N will be equal to, so cos 90 is 0. So 0 comma 1 comma 0, right? Because cos alpha, cos beta, cos gamma. Okay, I write it in same order. So alpha is 90 degree, beta will be 0 degree, right? Beta will be 0 degree and our gamma will be 90 degree. Now similarly for z-axis, right? For z-axis, what is the direction cosine for z-axis? Our gamma will be 0 degree and our alpha and beta will be 90 degree, right? Remember all three axes are mutually perpendicular. Our gamma will be 0 degree. In that case, our L comma M comma N is cos alpha, cos beta, cos gamma. So 0, 1 comma 0 comma 0, 0 comma 1 comma 0, 0 comma 0 comma 1 are the direction cosines for x-axis, y-axis and z-axis respectively, right? So we have seen what is meant by direction cosine of a line and then we have seen three important note based on direction cosine of a line, right? So next we'll be moving on to direction ratios, right? So we will define what's meant by direction ratios and then we will proceed with the next concept, right? So now we'll move on to direction ratios, right? So we define direction ratios, right? We will define what's meant by direction ratios, right? It's very simple, right? If if the direction cosine, if the direction cosine, right, L comma M comma N, right? We know L comma M comma N is the direction cosine of a given line. If the direction cosine L comma M comma N of a given line be proportional, right? Be proportional to any three numbers, right? Any three numbers A comma B comma C. Right? That is, if L comma M comma N is proportional to any three numbers A comma B comma C, then this proportionals, right? Proportional numbers A comma B comma C are called the direction ratios, right? Then the numbers A comma B comma C are called the direction ratios, right? Very simple, right? So if L comma M comma N are direction cosine, any three number that is proportional to L comma M comma N, that three numbers are will be direction ratios, right? I'll give you an example, right? Let us say we have a line whose direction cosine is given by 1 comma 2 comma 3, right? Just for example, we will take a line whose direction cosine is 1 comma 2 comma 3, right? Now what can be the direction ratios? There can be infinitely many direction ratios, right? So the path, there can be infinitely many direction ratios, right? So DC means direction cosine from now on. DR means direction ratios from now on, right? So what I'm going to do is I'm going to multiply throughout by 2. So therefore 2 comma 4 comma 6. If I multiply throughout by 3, then we will have 3 comma 6 comma 9. If I multiply throughout by 4, we will have 4 comma 8 comma 12. They multiply throughout by 5 comma 10 comma 15, right? So there are infinitely many direction ratios for a given line, but the direction cosine is unique. Very, very important, right? Direction cosine is unique. Direction ratios is not unique, right? So why? Because the same direction cosine, for the same direction cosine, there are infinitely many direction ratios. Why they are direction ratios? Because it is proportional to 1 comma 2 comma 3. What is proportional? That is 1 comma 2 comma 3 can be obtained by multiplying a suitable scalar, right? For example, if I take 2 common here, that is I can obtain 1 comma 2 comma 3 by multiplying 2 with it. That means these two are proportional. Proportionality constant is 2, right? And here, if I take 3, we can have 1 comma 2 comma 3, right? And if I take 4, we can have 1 comma 2 comma 3. That means these two are proportionals, right? These two are proportional. Yes or no? Yes. And similarly, you can have 5 times 1 comma 2 comma 3 and so on. So there are infinitely many direction ratios. This proportionality constant can also be equal to negative also. It can also be equal to fractions also, right? Okay. Okay. So that means if the direction cosines L comma N of a given line be proportional to any three numbers, then the number A comma B comma C are called the direction ratios, right? The only note, right? We will see some note. Okay, before note, we will write it mathematically, right? That is, this L comma M comma N and A comma B comma C are proportionals, right? That means what? That means what? That means L by A, M by B, N by C will be equal to some constant K, right? For example, if you divide this 1 by 2, 2 by 4, 3 by 6, you can see all are equal to 1 by 2, right? You can see when you divide these two, L by A, M by B, this our A comma B comma C because it's our direction ratios, and this our L comma M comma N. So 1 by 2 is equal to 2 by 4 is equal to 3 by 6, all will be equal to 1 by 2 if we simplify, right? So that means if L comma M comma N are direction cosine, if any Any three numbers that are proportional to L comma M comma N will be called as direction ratios, and this is the mathematical way of writing proportionals, right? And this is a proportionality constant can negative also, right? It can be negative also. I simply say this belongs to real number, right? I simply say it belongs to real number. Right? That means L is equal to AK, M is equal to BK, N is equal to CK. Right? That is this L comma M comma N is nothing but a multiple of a same number K with A comma B comma C. That's what written here, right? Very simple. Okay. Now we will see some note, right? So we will see some note based on direction ratios, right? So based on direction ratios. So note 1. Direction cosine is unique, but direction ratios need not be unique, right? Direction cosine of the given line is unique, but direction ratios can be infinite, right? It is not can be, it is infinite, right? Why I should why I should write can be? That is to simply say it is not unique, right? So direction cosines are okay, let us write are infinite, but functions are infinite. Right? This is the first important note. Now, given direction ratio, how to find direction cosine? Very important note, right? So how to find direction cosine with the help of direction ratio? If you know direction cosine, if you multiply by a suitable scale, if you multiply by some scalar, you will have different set of direction ratios, right? For example, if this is a direction cosine, if you multiply by 2, if you multiply by 3 throughout, if you multiply by 4 throughout, you can have infinitely many direction ratios. If you are given a direction ratio of a line, how to find the corresponding direction cosine, right? To find note 2, right? So note 2 is to find direction cosine, right? Direction cosine. If the direction ratio is given, if the direction ratio of the given of the line is given, right? Of the line is given. Can you understand what I'm saying? To find, that is, if you are given direction cosine, you can form infinitely many direction ratios. If you are given one direction ratios, right? How to find the corresponding direction cosine? And is what next question, right? Very simple. We know direction cosine is a unit vector. Yes or no? Yes or no? We know direction cosine is a unit vector. If I normalize the direction ratios, I can find the corresponding direction cosine. If I normalize, that is, if I make a direction ratio to be a vector of magnitude 1, then I can turn that to be direction cosine, right, for the given line. How to do? Very simple, right? If that is given a comma b comma c, right? Given a comma b comma c, to find L comma M comma N, we need to normalize this. So therefore, L comma M comma N is nothing but, you just normalize this. So A divided by root of A square plus B square plus C square, B divided by root of A square plus B square plus C square, C divided by root of A square plus B square plus C square. That is, the corresponding direction cosine can be found by normalizing the direction ratios. To normalize, what you need to do is you need to take each coordinate and divide by its length, right? That is magnitude of, root of A square plus B square plus C square. So this is our L comma M comma N for the given direction ratios, right? So these two are very important note on direction ratio, right? So we have defined direction ratios and then we have seen two important note, right? Now, next what we're going to see is, we're going to see what is a relation between direction cosine and direction ratios. That is, what is the relation between A comma B comma C and L comma M comma N. Remember, from now on, whenever I write L comma M comma N, this direction cosine, which is always unique for the given line. And whenever if I write A comma B comma C, it is nothing but direction ratios for the given line. What is direction ratios? is nothing but proportionals to these are any three numbers that is proportional to L comma M comma N will be the direction ratios, right? Okay. Now we're going to see what is the relation between what's the relation between that is what I'm going to do is I have said that if you normalize this, you will get L to be equal to A, M to be equal to this, N to be equal to this, right? We're going to prove this now, right? We're going to prove this. That is, we're going to see what is the relation between we're going to see what is the relation between direction cosine and direction ratios, right? So direction cosine and direction ratios. That is, I have said a linear algebra terms here, right? That is, if I normalize that vector, I can get a unit vector. Now, instead of saying linear algebra point of view, we will prove this with the known facts, right? Okay. That is, L comma M comma N are direction cosine, right? This is our direction cosine. This A comma B comma C is our direction ratios, right? These two are ABC are proportional to L comma. This can be infinite, right? Okay. Now, what is the relation between this L comma M comma N and A comma B comma C? That is what we're going to discuss now, right? We're going to discuss now. Okay. Now we know that. These two are proportions, right? The definition of my definition of direction ratios, L by A, M by B, N by C is equal to some constant K, right? Is equal to some constant K. That means we know L is equal to AK, M is equal to BK, N is equal to CK, right? L is KK, M is BK, N is CK. Okay. Now we know that L square plus M square plus N square is always equal to 1, right? By known fact. We have already proved this. Now, what about L square plus M square plus N square? It is AK whole square plus BK whole square plus CK whole square is equal to 1. So, if I take this K square outside, we'll be having A square plus B square plus C square is equal to 1. This implies K square is equal to 1 divided by A square plus B square plus C square. That means this K can be equal to plus or minus 1 divided by root of A square plus B square plus C square, right? A square plus B square plus C square. Now again, if this K is positive constant, this will be plus. If this K is negative constant, this will be minus, right? If K is positive, then our that is, this can be negative or positive. K is positive, then K will be equal to 1 divided by root of A square plus B square plus C square. Then what about, we know L is AK, M is BK, N is CK. Therefore, our L comma M comma N will be equal to, so L is A into K. So A into K will be A divided by root of, so okay, let us write it clearly. So L comma M comma N is AK, BK, CK. So this AK, so it will be A divided by root of A square plus B square plus C square, and BK, so B divided by root of A square plus B square plus C square, and C divided by root of A square plus B square plus C square. And again, if K is negative, then we have L comma M comma N to be equal to minus A divided by root of A square plus B square plus C square, and so on, right? If proportionally constant is positive, this is our L comma M comma N. And this the relation between L comma M comma N. If the proportional constant is negative, right? If K is negative, right? If K is negative, K is negative, then our L comma M comma N will be equal to, so minus A divided by root of A square plus B square plus C square. So minus B divided by root of A square plus B square plus C square, minus C divided by root of A square plus B square plus C square, right? So this is the relation between L comma M comma N and A comma B comma C, which I already discussed here itself, right? This L will be equal to A divided by root of A square plus B square plus C square. This M will be equal to B divided by root of A square plus B square plus C square. and this n will be equal to c divided by root of a square plus b square plus c square, right? So far we have seen what is meant by direction cosine of a line, and we have seen direction ratios and what is the relation between direction cosine and direction ratio. Now we'll be moving on to the next two subtopic, which is very easy, and then we'll wind off today's video, and in next part we'll be doing some problem based on these five subtopics, right? So second, the fourth subtopic is what is the direction cosine of a line joining two points, right? What's the direction cosine of a line joining two points? That is what we're going to discuss, right? Yes. Start the next subtopic, which is direction cosine of a line joining two points, right? So very interesting again. So what is the direction cosine of a line joining two points, right? So what is the direction cosine of a line joining two points? Right? Yes. So very interesting. So what we'll do is, so first we'll draw a diagram so that you'll have more clarity, right? So we'll draw a diagram here. So this is our let's draw the coordinate axis first, right? This is our x-axis, and this is our y-axis, and this is our z-axis, right? And this is our z-axis. Okay, x-axis, y-axis, and z-axis, right? So what we're going to do is, what is the direction cosine of a line joining two points, right? So there is a line. This is our line, right? The line PQ, right? So what we did in very first slide, what we did is we have just drawn a parallel line that is passing through origin. We have found the direction cosine to be equal to alpha, alpha, cos beta, cos gamma, right? But it is not that easy to find the line that is parallel to PQ as well as passing through origin, right? Before, that is instead of that concept, what we did there, we have drawn a parallel that is passing through origin. We have found the direction cosine, right? Is there any method other than that? Yes, right? What I'm going to do is I'm just going to find the direction cosine for this line PQ. By not using that concept, what I did there is I have drawn a parallel that is passing through origin and so on, right? Without that concept, I'm going to do this, right? Let us draw this line PQs somewhat more slope. Okay, this is our line PQ, right? Okay. Let us say this point is x1 comma y1 comma z1, and this point is x2 comma y2 comma z2, right? Let this point be x1 y1 z1, x1 y1 z1, and this point is x2 y2 z2, right? x2 y2 and z2. So we define the direction cosine of this line, right? Okay, so direction cosine of a line joining two points, right? Let p comma q comma let p comma line joining two points, right? Let p comma q pq be the line, right? PQ be the line with the p coordinate is x1 comma y1 comma z1, and the q coordinate is x2 comma y2 comma z2. So what we can do is we can also derive that formula with the help of this formula also, right? I'll do this. Okay, so we have a line PQ. We need to find the direction cosine for PQ, right? Okay, let the line PQ, actually, in exam point of view, you just by heart the formula, but I'm going to derive the formula now, right? Okay. Let the line PQ makes an angle alpha, beta, gamma with the x-axis, y-axis, xy, z-axis respectively, right? That is, let's draw right? This makes an angle alpha. Similarly, if you extend this and if you extend this, you will have beta and gamma. We will restrict only to alpha, right? Beta, gamma, we can write. I'm going to write that similarly. That is, you just extend this, right? Extend this here. You will be having beta, gamma angles also, right? Okay. So we have now what I'm going to do is let us what I can do is okay. Now if L comma if L and M, right? If L and M are the projection, are that is what I'm going to do is I'm going to project this PQ to the x-axis, right? The first I'm going to do is I'm going to project PQ to the x-axis, right? That is projecting PQ to the x-axis. So projecting PQ on x-axis. This is what first I'm going to do. So if I project, that is, if you just take a task light and just apply here, you will have a projection here, right? You will have projection here. Let us call this. Let us draw some different colors, right? So this will be the projection, right? This will be the projection. Let's call this as L. Let's call this as M. And this point is we know O, right? This point is O. This point is O, right? Projecting PQ on the x-axis. If you project PQ on the x-axis, let if L and M are the projections of the point P and Q respectively. That is, this L is the projection of P and this M is the projection of Q, right? Now, if L and M are the projection of the point P and Q respectively, right? Now, what is OL? What is OL? It is nothing but x1, right? Because this point is x1, this point is origin, so it is moving x1 distance. So OL is x1. And what about OM? OM, this point is x2, right? This point is x2, so that means OM will be equal to x2, right? And what about LM, right? What about LM? So LM is same as this, right? Let us call this as let us name some other variable, right? Let us call this as R. Let us use S, right? So RS is same as LM. So what is LM? Actually, LM is same as RS. What is RS? RS is nothing but what? This angle is alpha. This will be this distance into alpha, right? So that is this is nothing but magnitude of PQ into cos alpha, and this distance is magnitude of PQ into sin alpha. Yes or no? These are very elementary, right? Complex numbers area, right? So what we do in complex number is, if R is the distance from origin to the complex number, then the polar form is given by R cos theta, comma R sin theta. So this distance is R, this magnitude times cos theta, this angle is theta, this distance is R times sin theta, right? So similarly, this point is P, this point is Q. So this distance is modulus of PQ is the distance. So PQ into cos alpha. This length is this magnitude into sin alpha, right? Sorry, it is alpha, right? Alpha is the angle. So magnitude of PQ into cos alpha. This is magnitude of PQ into sin alpha. So RS and LM both are same. So therefore LM is nothing but PQ into cos alpha, right? So what is PQ? Where PQ is the distance from P to Q, right? Distance from P to Q, right? So what I'm doing is, first I'm projecting PQ on the x-axis, right? Yes, Q is the distance from P to Q, right? This implies, so what is cos alpha? So cos alpha is LM divided by PQ. Can I write LM to be equal to, what is this LM? It is nothing but modulus of PQ cos alpha, we know. It is also, this is nothing but x2 minus x1. What is the length of LM? This point is x2, this point is x1 in x-axis. So this is nothing but x2 minus x1. This can also be written as x2 minus x1 divided by length of PQ. So therefore, we have found cos alpha. That is, we have found L. Similarly, we need to find M and N also. So therefore, L is equal to x2 minus x1 divided by length of PQ. Similarly, you project PQ to the y-axis and you project PQ to the z-axis, right? I'm not going to do that. I'm going to write away directly. I'm going to do this, right? I'm going to do project PQ on y-axis, right? If you do on y-axis, you will have M to be equal to y2 minus y1 divided by length of PQ, And similarly, if you project PQ on z-axis, right? You're going to have, that is, you're going to get cos beta is equal to this value. Cos beta is m, right? And we're going to get cos gamma is equal to n is equal to z2 minus z1 divided by distance of PQ. So therefore, the direction cosine of the line joining 2 points, right? Of the line joining 2 points. That is, if x1, y1, z1 is one point, x2, y2, z2 is another point, the direction cosine of the line joining 2 point is given by x2 minus x1 divided by length of PQ, y2 minus y1 divided by length of PQ, z2 minus z1 divided by length of PQ. If not, what is length of PQ? Where PQ is equal to, what is the length of these 2 points? It is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. That will give you the length of PQ, right? Very, very important formula. Direction cosine of a line joining 2 points. You simply write it out. This is the direction cosine of the line joining 2 points, right? Now, this is the direction cosine of a line joining 2 points, right? So this is the direction of line joining 2 points. Very, very important formulas. L, M, N will be x2 minus x1 by PQ, y2 minus y1 by PQ, z2 minus z1 by PQ, where PQ is the length of the, that is the distance between P and Q, right? So now we'll move on to the last subtopic. After we're going to do some problems. So what is the projection of a line joining 2 points on another line, right? I'm just going to give the formula and then we're going to wind off, right? So what is the projection of a line joining 2 points on another line? That we're going to discuss, right? So last subtopic, very, very easy. I'm just going to give the formula. So projection of the line joining 2 points, right? Of the line joining 2 points, right? Let the point be P, x1, y1, z1. Projection of a line joining 2 points P and Q is x2, y2, z2 on another line whose direction cosines are L, M, N. That is what we're going to discuss now. I'm not going to discuss in detail. I'm just going to write down the formula, right? What is the projection of a line joining 2 points P and Q on another line whose direction cosines are L, M, N, right? So what it is, simply, very simple, right? So we have a line PQ, right? So we have a line PQ. So this point is P, Q. This point is x1, y1, z1, and this point is x2, y2, z2, right? So we have another line. Right? We have another line. This line has a direction cosine L, M, N. Right? If L, M, N. So what is the projection of this line to another line whose direction cosines are L, M, N? Right? What is projection? It is nothing but the shadow, right? So that means projection will be a number. So the projection is given by very simple, right? We have a line PQ, we have another line L, M, N. We're going to find the projection of PQ on this line. This line has direction cosine L, M, N is given by, I'm going to give the formula, is given by L into x2 minus x1 plus M into y2 minus y1 plus N into z2 minus z1. This is the projection you will be having if you project a line joining 2 point to another line whose direction cosines is L, M, N, right? I'm not going to prove this formula. You can, this is not required, right? You just by the formula, very, very important formula also, right? So we have a line PQ, and I'm going to project this line to another line, and that is what is the projection of this line PQ to another line. This another line direction cosine is given, right? Remember, if this line direction cosine is given only, then this formula can be applied, right? The projection is given by L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1. This will be some number, right? This is some. That's it. So in this class, in part 1, we have seen these 5 subtopics. In sixth, that is in the next class, we'll be doing some problems based on all these 5 subtopics, right? So that's it. So thank you. So again, this is the first lecture on analytical geometry. I thank you each and everyone for enrolling in this course. So I'll make sure this course will be a good experience for you, right? So thank you, all the best.